Thanks very much for coming out. My name's Jonathan Dogtrim, and I'm the practice lead for clean tech here at MaRS Discovery District. I'm excited to be moderating and hosting this morning. Energy is a huge part of the clean tech portfolio here at MaRS. In fact, about 50% of our entrepreneurs and clients are in the energy space. And those 50% actually account for about 85% of the capital that our clients were able to bring in the last little while to grow their businesses. So there's a lot of strength in Ontario in innovation in the energy sector. And smart grid technologies are a huge category or subsector within energy. And it's no surprise that we have that many energy innovations and smart grid technologies happening, because it represents a huge global economic opportunity. And within our practice, we see it as one of the key clean tech subsectors that will help lead to future manufacturing and job creation. Here in Ontario, we are the first jurisdiction in North America to have put smart grids on every small business and home. So we've got a really great start on things, but we're not alone in this pursuit of smart grid technology by any means. If you look at in 2010, China spent over $7 billion in developing smart grid infrastructure. The US spent a little over $7 billion as well. And Japan, Korea, Spain were all close to the $1 billion mark in investment in smart grid infrastructure. So those are some pretty big figures and some pretty scary numbers for us to try to compete with. But what this is about this morning is getting all the right people in the room so that we can try to coordinate our effort and try to compete and bring some of our own innovation into the marketplace. And in order to do that, the first thing that we wanted to do here at MaRS was try to get everyone on the same page. And I want to thank my colleague Jessica Briones over here for pulling together a white paper that really helps inform us what the various utilities are doing and what the regulatory bodies are doing around smart grid technology in Ontario. Very helpful information for all of our entrepreneurs and all of us as we try to work together and get these innovations commercialized. The other thing that's equally important is for us to understand where our specific strengths and skills are in the sector. So what we wanted to do was take a few minutes and introduce you just very briefly to some of the smart grid technologies that are in the clean tech portfolio here. And we have an infographic that actually contains 1 minute, very quick summaries from some of the CEOs and CTOs or entrepreneurs in these companies. So I wanted to just quickly take us through those. And I was going to start with the distribution side of the electricity grid. The first company that I'm going to show you, DTEX, we're joined by Roger Morrison. Roger, if you could just maybe wave to people so that afterwards people can get in touch with you. But it's interesting when you look at energy today, we know how much energy is produced and we know how much energy is billed, but there's a whole bunch in between that is difficult to understand. And Roger's got a technology that helps narrow in on technical and non-technical losses.
In 2009, in North America, Canada and US, it was reported $27 billion worth of technical and non-technical loss. Technical being approximately 60% of that, non-technical being 40% that. We can directly, at DTEX, address that situation and issue, dramatically reducing losses for utilities, dramatically reducing capital costs for utilities, and capital costs for consumers. What the tech system does is monitor the primary and medium voltage line, which monitors approximately 80 homes. We reconcile with smart meter endpoints to give utilities exact loss estimates. What we also do with utilities that do not have smart meter endpoints is reconcile with their billing data and give them highly accurate loss estimates. Further, automatically on an outage, we immediately wake up, notify the utility of the direct start of the outage, and dramatically reduces manpower in addressing those type of concerns.
We're also joined by Ken Scott, who is the CFO of Enbala. And Enbala is aggregating loads and doing second-by-second balancing on the distribution grid.
Enbala operates a smart grid network that helps electricity system operators balance supply and demand. We call this service grid balance. Historically, system operators have maintained this balance by changing the output of generators. Enbala has found a better way. We pay large loads, for example, industrial electricity users, to participate in the Enbala Power Network. The network captures flexibility in the way that the loads use power and turns it into grid balance. By flexibility, we mean the ability to increase or decrease power consumption over a short period of time. So effectively, Enbala pays loads to benefit from the smart grid. There are no upfront costs to participate, and the presence of the Enbala technology is transparent to the user. The user defines operating constraints, and the network works within those constraints. Smart grid means using computing and communication technology to help power system users optimize the grid. That's what Enbala is all about.
The next one to show you, still on the substation and distribution part, is ProLucid. So we're joined by Bob Lee with ProLucid. With all of the smart meters that have been deployed, you can appreciate there's a huge amount of data that needs to be managed so that we can effectively use it.
If the smart grid means anything, it means an electricity grid that's going to have to adapt and continue to adapt much more rapidly than it has over the last 40 years. Data would be central to this new grid and must be integrated in every system that you see deployed out there. ProLucid's technology platform provides the data collection, monitoring, control framework required to integrate devices, applications, and new technology in the grid. This reduces the total cost of ownership for utilities, producers, and other technology companies that want to get their applications quickly out into the grid. Our customers want to reduce their total cost of ownership for integrating applications to the smart grid. They have unique application requirements that aren't satisfied by existing products. Our technology is deployed to the smart grid to integrate these systems and centralize the management, control, and communications in one easy-to-manage solution.
We're now going to move over to the transmission and energy storage side. We're going to start with HydroStore. We're joined by Michael Dowbiggin. There he is. Who leads their project planning group. So HydroStore is using compressed air for energy storage, and they've overcome a lot of the existing geography constraints of compressed air. They're putting it underwater.
Renewable energy is great. Unfortunately, it's intermittent. We produce power when the sun shines, and we produce power when the wind blows. But when there's no sun or wind, where's the power? This is where storage comes in. Storage allows us to store the electricity that's produced when the sun is shining and use it when the sun is not. HydroStore stores power using underwater compressed air energy technology. Simply put, what we do is we take electricity from the grid, we convert it into compressed air using a compressor, and then we store that air in big flexible accumulators located below the surface of water. When the power is needed back at the grid, the weight of the water will push the air back to surface at pressure, and we will turn a generator with it and supply the power directly back to the grid. The storage offers a number of solutions to the grid. Not only does it remove intermittency of renewables and make them usable 100% of the time, but it increases the efficiency of existing assets such as transmission and generation. Really, there will be no future grid without the addition of storage.
The next one that we have is Hydrogenics Corporation. We're joined by Daryl Wilson and Vito Westbrook. One of the most dramatic ways that we could improve energy efficiency is combining energy on the electrical grid with other energy carriers or fuels, and that's what Hydrogenics is doing.
Hydrogenics and its utility partners are developing a transformative energy storage solution called power to gas. Today, we live in a world of energy silos. The electrical grid silo and the natural gas network silo work independently and with little interaction between the two. As part of tomorrow's smart energy grid, we're going to see the convergence of these two energy silos, and the bridging technology will be Hydrogenics' efficient and dynamic electrolytic hydrogen generator. Excess electricity is going to be converted into gaseous energy in the form of hydrogen using our technology. This gaseous energy will be injected into the natural gas pipeline network, thereby allowing the energy to be stored and transported. Once inside the natural gas pipeline network, the gas can be generated back to electricity by distributing it to existing power infrastructure when and where it is needed most. Power to gas will offer unprecedented energy storage flexibility for our smart energy grids and will relieve constraints on future renewable energy deployments without the need for costly infrastructure additions.
So next we have two more videos that are relate to a different part of the grid, the consumption side. First one I'm going to put up is MMB Research. And Daniel Lee, who is on the business development team with MMB, is here. So behavioral change is something that's really difficult to do. But what MMB is doing is they've come up with technology that helps to make behavioral change easy for consumers and allows OEMs to get into energy conservation.
MMB Research makes a hardware and software platform that makes it incredibly easy for manufacturers of all the energy-consuming devices around us to connect those devices to the grid and to the information we need to make smarter decisions about how we use energy. We all know we need to start saving energy. We also need to change when we use energy to reduce those swings in demand when we all use energy at the same time. But that's hard to do on our own. We're not all going to start doing our laundry at 2 a.m. What we need is a new generation of the devices and appliances in our lives that are connected to that information, like consumption, price, even how much our neighbors are using, and that can help us make better decisions about our energy use and maybe make smarter decisions for us. But that's not easy either. For these manufacturers, developing the expertise and technology required to do this is a huge and expensive task. At MMB Research, we've developed what you might call a wireless smart grid chip that already speaks the language of the smart grid and that manufacturers can easily add to new and existing devices and get them connected to the grid and to the information we all need to make saving energy incredibly easy.
Next, this is the last one. This is Regen Energy, and we're joined by Trevor Strauss. Regen Energy is an interesting one on the consumption side. They've found some low-hanging fruit. What they're doing is they're coordinating high energy demanding air conditioners and reducing the peak load for their customers and generating some really great quick paybacks for them.
So at Regen Energy, we've developed a very unique and patented technology called the EnviroGrid. The EnviroGrid is a control technology that we use for reducing a customer's electrical demand and consumption, typically in the small to mid-sized commercial industrial space. We attach one of our controllers, which is roughly the size of an iPhone with an antenna, to each one of the discretionary loads on site. Could be a rooftop air conditioning unit, a baseboard heater, lighting system, and our technology immediately forms a network which enables a higher level of intelligence to promote a reduction in demand. So our units talk together as a collective with a goal of reducing the overall demand of those systems. The benefit that we provide is obviously a reduction in demand and a reduction of consumption to the customer, but on a grid level, we're also helping to reduce grid stress and helping to also promote something called demand response, so that when the utility doesn't have enough electricity on the grid for everybody, they call for all those who can participate to drop their load, and our technology is an enabler for that. So that's the EnviroGrid technology and how we fit into the smart grid.
So I want to thank all of our entrepreneurs for taking their work and condensing it down into a quick minute pitch. It's not an easy thing to do, so we really appreciate it. So I'm almost done here. What I want to do now is just quickly introduce our panel and then hand it over to them. First of all, starting on the far end, we have Brian Warshay with Lux Research. And Brian is a part of the Smart Grid and Grid Storage Intelligence team at Lux. He's been tracking energy storage projects and technology all over the world. Sitting beside him, we have Alex Betancourt, who is the Managing Director of Smart Grid Canada. And Alex has been consulting in transmission and distribution in the utility sector for quite a while, and with a specific focus on control room operations. We also have John Mulrooney, Director of Smart Grid Technologies for PowerStream. And he covers all aspects of PowerStream's smart grid strategy, and he's on several committees helping us to set policy and standards in Ontario. And John, it was clear in the white paper that PowerStream is very progressive in this area, so we look forward to hearing more. And also Jonathan Norman, who is the Director of Transmission and Distribution Policy for the Ministry of Energy. So he's responsible for policy, grid expansion, smart grid, and feed and tariff programs for the ministry. Not an easy task. So I will now hand it over to Brian.
Thank you. Thank you for having me this morning. I appreciate MaRS putting on the event and all the other speakers that are here today. I'm very much looking forward to the back and forth that we'll have. What I'm here to present today, and what Lux Research does, is look at the global market opportunities and technology perspectives of the vast variety of smart grid technologies that are currently being implemented on the grid, and to look forward to those that will be implemented on the grid, and to give you a perspective of some of the drivers that are bringing these technologies to fruition. Lux Research focuses on emerging technologies. Our core business is to really speak with some of the technologies, such as some of the companies that are here today, to provide company profiles to our clients, which are often large investment firms or material and chemical manufacturing companies from around the world, to help advise them on their business development. We cover a variety of different tech sectors. I focus on smart grid and grid storage. We also cover electric vehicles, solar systems, alternative fuels, bio-based chemicals, and a variety of others. We have offices around the world, but our focus is on science-driven technical research, with over 2/3 of our staff with science degrees. On the smart grid and grid storage team, we focus on 3 core areas: the smart grid and grid hardware, grid storage, and fuel cells. Within these areas, we focus on answering questions for our clients, such as which technologies will succeed and why. What is the market size? What does the market look like? And what are some of the regulatory drivers bringing this technology to market? Some of the questions I'll focus on a higher level today are: what is driving smart grid technology adoption? Why are these technologies important? Where is the investment taking place? How regulations incentivize and constrain the market? And specifically looking at Ontario as a case study. At Lux, we look at the smart grid as a large and multifaceted conglomeration of different technologies at all different stages of the grid, from generation side all the way down to the meter. And what we've noticed in our research is that though there is an increase in sales of smart grid devices, the main thing that utilities are having to deal with managing is the vastly increasing supply of data that is coming in from all these different devices located throughout the grid. The big question for utilities is, what do they do with all of this data? So most smart grid tools are very directly aligned with the goals of utilities to provide safe, reliable, and cost-effective electricity to the consumer. But as I mentioned, there's all this data coming in. How do they manage it? Well, we look at the different technologies based on the type of data and the quantity of data they're producing. Smart meters, for example, are bringing in a high quantity of data, but each individual bit of data is of relatively low value. To contrast that, fault detection, isolation, and repair technologies are probably much lower in the quantity of data, yet that data is highly valuable. So it's very important for utilities to have the right technologies and the right data management systems to control and evaluate and analyze this data to avoid outages and to provide the most efficient system to you, the end customer. So the thirst for this data is driving different technology adoptions at different scales. There's multiple layers of the smart grid. The first one, which Ontario has done very well with, is the smart meter, where Ontario has, I think, 100% smart meter adoption throughout the province. Utilities, however, are the important focus of a lot of our research because as we see looking forward in the next decade, utilities will be providing almost 3/4 of the investment in smart grid technologies around the world. And this is 3/4 of a $34 billion market by 2020. There's also a lot of private investment and acquisitions going on in the smart grid market. What we've noticed is that over the last 2 years, it's been a very up and down market, with early 2010 having a spurt of investment, late 2010 with a significant slowdown, and then early 2011 having another increase in investment. One of the emerging trends that we were able to pull from our data and evaluating different venture capital funding is that almost 3/4 of the investment coming into the smart grid market is in Series D or later round funding for emerging technology companies. So the investors are really looking for more mature technologies that can really prove themselves on the grid and that have active, ongoing demonstration projects to prove their technical capacity, reliability, and economic effectiveness to utilities, which are inherently and often risk-averse. There's also been significant merger and acquisition activity, with several large multi-billion-dollar deals going on over the past 2 years, and with a lot of recent acquisition activity focusing on meter data management systems from some of the large electric suppliers, picking up some smaller pieces of the data management pie. But the private investment pales in comparison to government spending within the smart grid as a whole. China alone has committed $310 billion over the next 5 years towards smart grid technology and upgrading its grid as a whole. Different governments around the world have different approaches towards incentivizing and pushing smart grid technologies. Smart meter mandates and grants in the European Union, for example, where by 2020, 80% of EU member states must where all member states must install smart meters at 80% of their customers with 100% deployment by 2020, is a direct incentive for smart technology adoption. The pay-for-performance ruling in the United States for frequency regulation is another direct way that policymakers are incentivizing market strategies for smart grid technology adoption. Then there's indirect ways that policies can provide incentives for smart grid technology adoption, such as emission regulations on fossil fuel power plants, which indirectly incentivize renewable technologies that are often intermittent and therefore need smart technologies to manage the different loads. And then politics as a whole often constrain progress. There's regulatory uncertainty on different policies and tax incentives, especially in the US and also in some areas around the world. And there's also the status quo inertia of utilities that are typically slow to move, who often wait for regulatory and market change before they move forward with any innovative strategies, because their primary goal is reliable delivery of electricity. But Ontario has been doing a great job with smartening up their grid. Just in the past year, Ontario's electricity supply, wind component of their electricity supply, has increased by 40%. There is a feed-in tariff that's been incentivizing different renewable energy technologies both at the micro and the macro scale. Ontario has also implemented time of use electricity rates to all of its customers, which is something that's really going to hopefully incentivize both commercial and residential customers to take a better look and closer look at their utility bills and how they can save money by reducing load on the grid. Additionally, Ontario has over 500 megawatts of demand response on the grid already, which was able to help reduce the peak load during the highest peak last summer. And as I mentioned, 100% of Ontario's meters are smart. There are also several interesting demonstration projects going on in Ontario, and I pulled out a couple. Energate has a pilot project that is allowing customers at the residential level to control and monitor their energy consumption, as well as providing consumer-connected demand response aggregated with the system. Mbala, who's sitting right here in front of us today, has several projects in North America and Canada that are very interesting with the automatic autonomous demand response that is going to certainly be very valuable in the current US market and increasingly so throughout Canada. So as a takeaway, what is driving technology adoption? Smart meters are laying the foundation on the smart grid, but it's the resulting influx of data that it was alluded to earlier that is really driving new markets. Smart grid technologies are important to utilities because they align with the utility's goal to provide reliable, safe, cheap electricity. Investment is coming in much later stage companies as this market sector as a whole matures. And acquisition is coming to earlier stage companies that have good software technologies that are cost effective for bigger companies to snatch up. Regulations both incentivize and constrain the market, and it's important for regulators to remain flexible and adaptable to changing market and technology conditions. And lastly, Ontario is a leader in smart grid technology adoption and has the correct policies and technologies to move forward in a very productive way. Thank you very much.
This is our clicker. Right on. Hi, I'm Alex Benincourt. I'm from Smart Grid Canada. If we'll pull up the presentation and we'll get started. So what is Smart Grid Canada? About a year and a half ago, some of the major utilities and industry players got together to say, we're at the edge of this transformation that's going to happen over the next decade in the electricity sector, and Canada needs an organization that helps promote a smart grid that's for the benefit of all Canadians. Canada is in this very unique situation where the great majority of our utilities in the country are publicly owned. The United States, that's not true. Europe, that's not true. Asia, that's not true. In the majority of the world, utilities are privately owned, private enterprises for profit, making a rate of return. Whereas in Canada, our utilities are owned by municipalities or provincial governments. BC Hydro, Hydro-Quebec, Hydro One, Power Stream, Meridian. These are all agents of the governments and therefore for public good. And we have this opportunity in Canada to make our smart grid in a way that improves the life of Canadians. Some of our members are here. We have major utilities across the country. We have major industry players across the country, and we have major academics across the country. And as an association, we're not alone. Canada's not the only one in this space working at Smart Grid. So Smart Grid Canada, along with all the other smart grid associations around the world, get together on a regular basis to discuss, where are our respective weaknesses and strengths. And in conversations with these other countries, Canada's very typical. We do a great job, but not a great job promoting ourselves. Whereas countries like Korea and Japan are really promoting their smart grid. And when I look at the brass tacks of it, they're not any further ahead than we are. We're actually much further ahead than the great majority of jurisdictions. But if you would go to a global conference, if you go to the World Economic Forum today, I'd imagine they would see that, no, it's the other countries in the world that are leading smart grid. It's China, it's Korea. However, Canada has deep, real smart grid implementations, real money being spent in the space. And I think globally we need to do a better job of promoting ourselves. And I know that the Ontario Ministry of Economic Development is doing a lot of great work in that area, and the Department of Foreign Affairs is doing a lot of great work in that area, but I think we need to do more. So I'm going to gloss over this because I believe everybody probably knows why smart grid's good. Essential to our economic prosperity, our infrastructure is aging. So this is something that's very core to the utilities. And it's something that we forget in all this new whiz-bang technology. Utilities laid down an infrastructure 50 years ago that served us well, and that infrastructure is old, and it needs to be replaced. And we can try to use new technology to squeeze a few more years out of it, but for the most part, at some point in the next 10 years, a lot of the power transformers we laid down, a lot of the switchgear we laid down, needs to be replaced. These are mechanical devices. They're made out of steel and oil and real things, and these things break down. However, if we are going to replace these, let's replace them with new devices. Let's replace them with devices that leverage new technology, wireless technology, for us to employ all the smart grid applications that you've heard talked about today. Conservation is the cheapest way to accommodate load growth. It's that simple. We can either build a new nuclear power plant, or we can try to use less energy. Canada, I'm not sure if it's still true, but we used to be the biggest user of energy in the world. Now it's cold, we have long distances, it's understandable. I don't think we're wasteful as a country, but we use a lot of it, and there's ways for us to start using less of it. Clean economy requires renewable energy, and that requires a smart grid. You know, we've talked about energy storage technologies, we've talked about volt-var optimization technologies. These are the things we need in order to accommodate this. Outages cost money. In Ontario, we have, you know, there's really a divide. There's a urban outage statistic, and there's a rural outage statistic. And, you know, the physics of long lines out into the rural areas and forested creates outages. But there's ways for us to use smart technology to find the outages faster and restore those outages faster. And then the other thing is there's this horizon, just over the horizon, there's electric vehicles. And I personally think this is a really big opportunity for power companies, utilities. Every single time we go to the pump, we're putting money in and we're giving those dollars to the oil industry. At some point, as electric vehicles start coming up from the 0.1% to the 1% to the 5% to the 10%, the dollars that used to flow to the oil industry will flow to the power industry. And that's a major shift of economic power, and it's a major opportunity, especially in Canada, because those utilities are publicly owned and are for the public good. And I think it's an opportunity that we don't see yet because we don't see a lot of Chevy Volts on the streets, but in 10 years' time, you know, this is going to be a real factor in our society. So, what I'm encouraged by Jessica is talk about where the opportunities are. And what we try to do is we try to think through, you know, where are the unconventional opportunities that are still left in the space that entrepreneurs can chase, and things that Ontario has a natural advantage in. So the first one I want to talk about is time of use rates. So if you see that picture there, right, that picture at the top, that is from the stopsmartmeters.org website, right? In California, they hate smart meters. And this is not, you know, this isn't Texas hating smart meters, this is Berkeley hating smart meters. Smart meters that are meant to increase conservation, reduce use of fossil fuels, these are all public environmental goods. Smart meters is a good. In Ontario, to contrast that, we've had our grumblings, we've had our negative press articles. There are some people who don't want their smart meters. But for the most part, if we contrast our experiences, the Ontario smart meter implementation, which is nearly done, and to a credit to the Ministry of Energy and all the utilities, has been done well. And that communications, that marketing, that's a service that people pay a lot of money for. And the Ontario companies that were engaged in getting consumer buy-in for smart meters can resell that service globally. And the rest of the world, you know, America has some jurisdictions that already have their smart meters, but the rest of the world is just at the beginning of this. And I think there's an opportunity for the ad agencies and the communications firm and the public relations firms that were engaged in Ontario to sell those services globally. I'm not sure if is there anybody in the communications marketing ad agency space in the room? A couple, right? So thank you for coming. I think this is a great opportunity for you to sell globally, as well as across Canada. You know, Quebec's going to start their meter implementation. BC is going to start their meter implementation, but this is a big global market. The next one is time of use rates. We are really the first jurisdictions with mass implementation of time of use rates. Everybody wants to get there. Most people just start with the smart meters. The learnings we'll have here are things that can be applied to the rest of the world. And then the last one is telecom over our rugged terrain. You know, it's Canada, it's rocky, it's hilly, it's forested. And the telecom challenges that we need to deal with, if we can solve them here, we can solve them anywhere. And the telecom that we're using for our smart meters and our smart grid is something that we can resell around the world. Next one. So Canada, 34 million people. Our population density is 230th in the world. There's like 3 other countries that are less dense than us. Right? We have 300 communities that are remote, off the grid, on diesel, and they only have 200,000 people amongst those 300 communities. There's an opportunity. Canada's going to have to solve the power problems of these communities, and that's an opportunity for us to sell that around the world. We're using hydrogen-assisted renewable power that Hydrogenics is working on. We have wind diesel storage. We have community energy management. We have hydrokinetic turbines. These are all technologies that we need for our own remote communities, and there's an opportunity for us to sell that around the world. The next one is the generation gap. So, one of the, when you look at our renewable program in Ontario, this is the picture that they were looking at in 2008. If you see the bar charts as they come down, that's our existing generation fleet as it was in 2008. And as that existing generation fleet gets decommissioned because they're getting old, you'll see the coal is the gray part that's stopping in 2014. That gap between those lines of our load growth and our existing generation fleet is the reason why we put so much energy and time into renewables. That, along with new natural gas plants and a bunch of other solutions, are what's required. But we had this real generation gap that we're facing and that we're dealing with. People sort of forget that. This isn't just about environmental policy. This is really about producing the power we need for the economy. The one thing Ontario is doing very progressively is putting that renewable energy everywhere. Right? In most other jurisdictions, this renewable energy is connected to the transmission grid. In Germany, in Spain, these are big projects connected to the transmission grid. In Ontario, we have big projects connected to the transmission grid, but we also have medium-sized projects connected to our distribution grid. And the technologies around voltage regulations, energy storage, energy management, market innovations on how we can use these for other things than just producing of power, and the protection and controls, these are all things we're going to figure out first in Ontario, because we're the ones who have the biggest penetration of this distributed renewable energy. And there's an opportunity for us to resell this around the world. The last point, with my last 7 seconds, is this is Korea's smart grid strategy. They, by 2030, will have the whole country smart grid. By 2020, they'll have all their city smart grid, and by 2030, they'll have all their rural part smart grid. This is a national strategy made by their Ministry of Energy, and all of their companies, the Samsungs, the Hyundais, the LGs of the world, have been told, you will buy into this, and this will be the strategy for the country. Now, Canada doesn't have this type of oligopoly-style command control infrastructure, but there is a role for both provincial governments and federal governments to set a national strategy for Canada to make sure that we're efficient with our energy. This was the first era, big plants. That's what served us for the last 50 years. This is the next era. It's about sustainability. And at that, I'll bring it over to John.
Good morning. When MaRS approached me a few weeks ago to address the audience this morning, they said, you have 10 minutes. And I said to my wife, I said, my God, I've given eulogies longer than 10 minutes. And the subject area, smart grid, is such a big part of the utility environment today. My topic, implementing smart grid, utility best practice. I looked at the host of issues that I could bring to you this morning. And knowing the diversity in the audience, I said what I have to be careful of is that, first of all, I stay within our time frame, and secondly, that I give you something to take away this morning. And so what I chose is to talk about the framework upon which we, as distribution companies, frame smart grid, make our smart grid decisions. There's a lot of money involved here, and there's a lot of responsibility in making sure that that money is well spent. Okay. Advancing. Here we go. Okay. What is best practice? Utility best practice, any best practice is a method or technique that consistently has shown results to be superior, and those achieved with other means, and they typically end up getting used as benchmarks. Best practice comes from experience. The Ontario LDCs, we've got years of experience. We've developed many best practices in areas such as planning, engineering, capital, and M&A management, and operations. We've got lots of experience to call upon. When it comes to smart grid, the final judge of what utility best practice is our regulator, the Ontario Energy Board. We have a monopoly situation. We are monopolies for electricity distribution, and with that comes the responsibility to ensure that we spend our money in prudent and useful fashion. There are two overarching must-haves that I put together for this presentation this morning, and I think this is fundamental to a smart grid strategy plan for not only local distribution companies, but anybody in this smart grid service sector. Foremost is the belief that the initiative, any smart grid initiative, must benefit the customer. If there's no customer benefit, then I ask, why is the LDC doing it? We have some initiatives that have come forward. It's going to make the life of the control room operator better, improve their situation. If that doesn't translate to a benefit to the customer, then that initiative shouldn't go forward as a smart grid initiative. The other overarching must-have is that smart grid initiatives get no free ride. There's a great tendency with all the hype that's in our industry about smart grid to give smart grid, everyone wants to be there. They want to be in the forefront and be part of that movement. That sometimes tends to put emphasis on initiatives, smart grid initiatives, that under closer scrutiny make no sense. And going back to point number one there, if it's not to the benefit of the customer, then why are you spending the customer's money to do it? So I'm just going to explain these 2 points and try and put this into context for our spending framework. Best practice to identify smart grid initiatives. This whole best practice starts with a smart grid strategy and multi-year plan. This is probably the biggest thing that utilities have taken away from the smart grid movement, being able to develop a plan. These aging assets that somebody, a prior speaker, referred to, these have to be replaced. Let's replace them with newer technology, smarter technology. The smart grid strategy and plan has to be tied to the LDC's corporate vision and the corporate objectives, and approved by its board of directors. This is not much different than how utilities have been handling capital spending in the past. Point two, that each smart grid initiative must make business sense, and again, I emphasize, benefit the customer. You say, how do you judge the value of a smart grid initiative? One of the key areas that we look at is the benefit-cost ratio over the life of the initiative. And if that's not greater than 1, then we say, why are you doing it? You're spending money in an area where you're not going to get your money back. And businesses, many people in this room, you do this daily with your own business, so it's, this is not rocket science. But this is where the prudence of the initiative is checked. You have to check that, do that prudence check before you get your initiatives into your prioritization and selection of what you're going to spend your money on. Point 3 is very important. Point 3 says that you have to look at collaboration and, with other industry stakeholders. There's a lot of experience out there. Nobody wants to reinvent the wheel. Prioritizing smart grid initiatives. In any LDC, probably like most companies that are represented here, there's usually a demand for capital more than there is capital available. And so you have to have some way of saying how do we select our capital projects. Smart grid initiatives, we believe, should undergo the same rigor as every other corporate initiative in competing for that limited capital funding. Extremely important. The Smart Grid Initiative has already passed the prudence test, otherwise it wouldn't be in the mix. So now you have a number of initiatives, capital initiatives, that you have to prioritize. And different companies have different systems for doing this, but typically you look at the benefit of any initiative, any spending, versus the risk to the corporate objectives, to the strategy and vision of the corporation. And there's some great tools out there to do that. But the smart grid initiatives are all part of that overall mix. This is the slide I started with. I'm sure you're wondering what it is. But I put the slide there for this reason. It is so easy for any organization to get caught up in the hype. And what this slide was trying to depict, you'll probably see, I think it's a Harvard trainer that's been adapted to a rock. And I know from flying days, model flying days, that with enough horsepower, even a rock can fly. That doesn't mean that that's the right way to go or the right thing to do. And I think that really drives home the point that we have that responsibility to make sure that the initiatives that we choose are the right initiatives and not just initiatives that with enough money we know can make it work. I hope I've left you with a couple of thoughts. Just remember, customer and making sure that you do the right analysis, the benefit-cost ratios for smart grid initiatives. Thank you very much for your attention this morning, and thank you to MaRS.
Well, thank you very much, and I'd like to thank MaRS for putting on this event today, and our panelists for their insightful presentations today as well. What I wanted to do was maybe build on some of the discussion that's happened here to date and focus a bit more on what we're doing on smart grid in Ontario and what's driving it, and where those drivers are likely to lead us. And I think that builds nicely on what you've heard from our panelists today. One of the things I always start with, and I don't take credit for this slide, it's a slide produced by the Electric Power Research Institute in the US. But it's really a good overview of what we're talking about when we talk about smart grid. We have a conventional grid. It delivers power. We get our electrons every day. Smart grid is really about modernizing that in the sense of putting an intelligence layer, communications layer on top of that. So in other words, other industries have kind of undergone a revolution, towards IT and communications technology. Telecoms industry is a great example. The electricity industry, not so much. And electricity today, particularly at the distribution level, is delivered much the same way it was 100 years ago, with some very, very ingenious operators like John Mulrooney that keep your lights on using that pretty standardized technology. This is an opportunity to provide things better, but it involves a capital expenditure, obviously, for all this type of ICT equipment, many of which, there are people here in the room today that provide that type of equipment. And what they're really doing is adapting existing technologies. And this isn't necessarily new technologies, but it's new applications for the electricity sector. And that's the challenge and opportunity in smart grid. And as I think you've heard today very clearly, it's not just happening here, it's global. It's happening all over the place. Everyone is talking about smart grid. There's a few quotes there, it goes across political lines. But what I would leave you with on this slide is that I would disabuse anyone that has the notion in here that smart grid is a goal. I don't think, as I work on smart grid and try and develop smart grid plans for the province of Ontario, that smart grid itself is a goal. Smart grid is a tool that can allow you to achieve all kinds of goals. And one of the challenges in defining smart grid, and why conversations sometimes go a little hairy on this subject after a while, is pretty much every jurisdiction in the world has different goals as to why they're pursuing this. So I want to go into a little bit about what Ontario's goals are, because I agree that Ontario is actually a leading jurisdiction in this. But it's for some very specific reasons, and we're certainly not leading in all areas. The corollary to that is that it's not a goal, so you never get there. You don't lay out a smart grid plan and say, okay, in 2025, I'm going to have a smart grid. It's a journey. And that journey is going to be consistently evolving, and you're going to be consistently transitioning your electricity system, and it's going to involve more and more ICT, and as a result, more and more data. And that data is going to give you lots of opportunities to manage your system better, and it's going to require you to manage it as well. What's pushing it in Ontario? Well, at a high level, like anyone else, we have to modernize our old infrastructure. Alex had a great slide showing some of that infrastructure aging, and we're moving towards a cleaner grid. At the same time, yeah, we're moving towards more distributed energy, but we want to maximize the use of our existing assets. We don't want to have to put new hard wires and poles all over the province and make Ontario into a copper plate. That's going to be pretty expensive. So we want to try and use our system intelligently so we can maximize those assets. We also, and this is important for reaching out to a customer, we want to move away from this model that we kind of have today where a utility operator has to balance supply and demand all the time, and they're kind of blind to their loads. They just have to kind of stochastically manage wherever their loads are going to be in the future and be able to provide for that. Smart grid at its heart is a link to that load. It's a link to the residents. The smart meter is the heart of that link. And there's all kinds of other things we can do to try and enable a utility operator to interface better with customers. And at the same time, engage customers more in the electricity system. Specific drivers for smart grid here, we have a very aggressive integration of renewable energy. The feed-in tariff was one of the most aggressive in the world, has resulted in thousands of megawatts being built right now on the system of wind and solar energy, and it is going to result in thousands of more. A lot of that, unusual compared to other jurisdictions, it's not being integrated all at the transmission level. When I speak to Spanish grid operators, despite their penetration of wind and solar energy, they are looking to Ontario on what it's doing on the distribution system. Because, and even the extent that Germany is looking at distribution system integration, I'll leave you with one quick stat. On average, German utilities, 480 customers per kilometer of line. In Ontario, Hydro One, 11. That's very difficult. That's a different management problem, operational problem for that utility. And it's an operational problem that drives smart grid. We've mentioned before, we have one of the largest smart meter rollouts, was the first in North America. We're also the only ones in the world to mandate time of use pricing. So time of use pricing has been used for a long time. It's typically voluntary. We're taking a different approach in Ontario and actually mandating it. So this is almost forcing some customer change or forcing engagement. But the other thing I would point out is, while all this is happening, we have great companies, many sitting here, operating in this space, and we have tremendous industrial strengths. So we have a real economic opportunity here as well. We mentioned leadership on smart meters. We have almost 5 million meters rolled out. Really, the key to this slide, and this has actually been presented to senior ministers to kind of engage them on what is this smart meter thing. Well, to most people, it's about time of use rates. These things provide a lot of benefits. In fact, other jurisdictions rolled out smart meters for a lot of reasons other than wanting to charge time of use rates. In Italy, it was to avoid theft of power. It certainly helps with outage management, and it provides all kinds of potential benefits in integrating distributed generation. So we want to build on that platform. What we've done here from a policy level is we've said, okay, we have really progressive utilities like PowerStream. I also see Viridian in the room here today. But we have 80 utilities. We have a regulator, as John has pointed out. Fundamentally, he reports back to the Ontario Energy Board. How do we create a structure so that people are taking this new environment and are able to actually move towards an asset management plan, a smarter asset management plan that achieves specific objectives? And the objectives we focused on were really in 3 areas. And these are what I would call the goals of smart grid in Ontario. The first one being customer control. So how do we get the customer more engaged? This is behind the meter. How do we link them up so that they're taking advantage of time of use rates, can move more towards home energy management systems, some, again, of which there are technologies by companies represented here today, and move towards better load control, two-way communication flow with the utility. At the end of the day, that'll result in more conservation. How do we make the power system more flexible? So I liked John's schematic at the beginning, where he was really giving examples of the different companies here, but that's a really good array of technologies, some on the customer control side, some on this power system flexibility side. What do we mean by that? We mean distribution automation and information for the grid operator. They don't have visibility on the system to the extent you would want them to. They can't integrate wind because it's a variable resource and they can't see it and they can't control it. So how could we put technologies in that have wireless infrastructure that allow for more automatic control, help us understand line losses better, help us deal with outages better, which have real dollar value benefits? Once we show those benefits, we move ahead. The last one is kind of a catch-all, but maybe important to put in place, especially in a legislative framework. How can we think about our infrastructure being more adaptive? So we're not in a rigid kind of, this is how we did it for the past 50 years mindset, so we're going to keep doing that. We're thinking about the things that are going to change in the future. The best example I could give of that is electric vehicles. So we don't know what the market penetration on those things is going to be. We know they're coming and could present problems and opportunities for utilities. So how can we take advantage of mobile charging infrastructure? Just to leave you off with a few of the specific initiatives going on, all those pushes and pulls mean there's a lot of stuff happening on the ground. But I think, as was pointed out at the beginning, we're not out there enough. We're not explaining this well enough. Hydro One has a smart zone that's world-class, looking at integrating DG in rural areas. Toronto Hydro is working on one, different objectives, reliability and control with different technologies. Burlington, PowerStream, I think you heard a bit more about, Viridian, are all doing similar things. The industry here itself is ramping up. We're engaging better with industry, including the regulator, recognizing that the industry has solutions that can be of benefit to the electricity system. How do we link the regulator with the utilities and the industry? So they have the OEB has a working group on smart grid. We're trying to outreach to small and medium-sized businesses. We also have a fund that's looking at particularly at Ontario-based companies that provide these kinds of technologies. How can they demonstrate them better on our system? We're also trying to look at what those economic opportunities are. So a group of 5 very senior civil servants, deputy ministers, looking at the fact that Ontario has real energy strengths. What are the global drivers and trends behind that? What are our assets in this area? How can we leverage it better internationally? And I think you'll hear more and more coming out of that over the next year. The opportunity at the end of the day, we've heard about this, but these are 10 to hundreds of billions of dollars of opportunity. In Ontario alone, the Smart Grid Forum has estimated that we would be investing about $390 million per year over the next 5 years on smart grid projects. That's just in Ontario as a proving ground for a lot of the tremendous innovation that we've seen and is represented here. So thank you very much, and I look forward to the panel discussion.
Thanks, John. Thanks very much. So what I want to do is I just want to throw out some questions, and we'll also take some questions from the floor. So there's mics positioned in the room if people want to approach those. Just to get us kicked off, one thing is that a lot of our discussion has revolved around what's going on in Ontario. For most of our entrepreneurs, they have ambitions well beyond 34 million customers, and they want to reach outside of Ontario and Canada. And I'm wondering if when utilities implement programs here, if they have the ability to leverage that experience and expertise into other markets. And if not, I'm wondering who at the end of the day has the economic mandate to see what we're going to do to get our technology out to the rest of the world. I open it up to anyone who wants to comment. Yeah, go ahead, Brian.
One of the things we look a lot at global opportunities in smart grid and all of the areas that we cover. And it varies, the simple answer is it varies tremendously from country to country. So there are tremendous opportunities, mainly in the developed world, and if you want to include China in that as well, for these technologies that are kind of homegrown here to get distributed out. One of the best ways to do that we've seen is through partnerships with larger companies that have a headquarters or stronghold, for example, a Siemens or a Schneider in Europe, and kind of having your technology add value to their total package. And a lot of time we've seen these larger companies pick up or partner with a smaller startup company to try to do a pilot to just see, is this technology viable in different grids and different opportunities elsewhere. We've also seen foreign investors coming to North America to find investment opportunities to kind of use North America as a test bed for different technologies. One of our clients we're working with now is looking at some advanced metering infrastructure deployment pilot projects, and they want to come in as an investor here to have the pilot project in potentially the Northeast or somewhere in the US. And then once if that proves successful, they can then take it back home to their country. But again, different countries have different drivers. For example, Japan is an island nation. It really needs to produce all of its energy by itself, does not want to be dependent on foreign powers, and is really looking towards renewables, especially in the wake of the recent disaster. So there's huge opportunities there for energy efficiency, smart grid technologies, and different technologies at all stages, all levels of the grid.
Just to pick up on something that Brian was talking about, was that one of the issues in the industries, especially for startup companies, is that utilities are used to doing business with, I heard it referred to in December, I've been repeating it since, the six sisters: GE, ABB, Alstom, Areva, Schneider, and Siemens. I always forget one. It's always different which one I forget, but it's always, those are the six companies utilities are used to doing business with globally. And I was down in Silicon Valley recently, and I was talking to some of the venture capitalists, and they were saying, you were talking about how it's all Series D investments, meaning that these are companies that already got their seed money and have gone through multiple these are companies that are almost going to IPO. All of the actual investment that was going on now isn't from like the startup angel investors. It's from Siemens strategic, Electricity de France strategic investment. Like, it is big companies gobbling up little companies. Now, you can argue whether that's good for the industry or bad for the industry, but one of the fundamentals in the industry is that those six sisters are the ones that sell most of the services to global utilities, and the opportunities for the entrepreneurs is to start something that they're not able to do on their own and be bought up. To do it the other way, to grow organically, I think is the more compelling story. It creates far more jobs in Ontario, but it's probably harder for the companies to grow. And I've heard that from lots of little companies in Canada.
Thanks very much. Another question that I have is, when it comes to planning out demonstrations and pilots, it's my understanding that we used to actually have a governing group that had some funds from the ratepayer base and could strategically kind of pull everyone together and coordinate some projects. What kind of coordination is going on now? Is there room for more coordination? Where are we at with the individual utilities?
A point that I didn't stress in my presentation, these pilots and demonstration projects, they are coordinated with smaller businesses. And to Alex's point, while the Six Sisters are there's new affiliations coming out of associations with smaller business. But the whole business with pilots and demonstrations is that, again, as an LDC, we've got to look at pilots and demonstrations that are going to lead over a reasonable period of time to a technology that we can adapt. And then I go back to my other points that I left you with. At the end of the day, the adoption of that technology has got to benefit the customer in some way. Higher reliability, greater efficiency, lower cost. There's a whole group of benefits that tie into many smart grid initiatives. But the coordination of these initiatives is really part of the reason that we're participating here today. There are companies out there, and some of you I know we have talked with about their technologies, trying to find that fit. And because every distribution company in Ontario, I think we're up in the high 80s now with the LDCs that are left, down from 300. But every utility is in a different part of its maturity curve with smart grid. And so the utility that's down very low is going to have a different emphasis on something like storage technology than a company that like a Hydro One, where they're very high on their technology evolution scale. So coordination is a one of the big efforts that we have, and it goes back to collaboration throughout the industry, not only in the LDC sector, but with the folks that are represented here this morning.
Okay.
Yeah.
Go ahead, John.
So, and I would agree with John on the importance of understanding the value to the customer from everyone involved. If there's value to the customer at the end of the day, which I think in most cases there are, and it can be shown, you're on safe ground. One of the things I heard interestingly from some members of the investment community is when they see, and they look at different types of infrastructure projects, when they see a project where their end customer is an energy utility, that's when they start running the other way. And I don't mean that to be in a disparaging sense. I think everything we've talked about today is a tremendous and very real opportunity. It's a question of how we actually do create those partnerships. And I think things are changing. I think, first of all, you're seeing utilities acting very seriously on demonstration projects. You're seeing a regulator looking at those demonstration projects and looking at how to coordinate them for the benefit of the customer at the end of the day. You're seeing a government trying to put in a legislative framework that facilitates that coordination, and a recognition amongst all of these players that we're not getting our message out there well. So there's really two kind of objectives here. How do we get our domestic market to be really what's a good testing ground? It's not the end market, our 34 million people. but it's a tremendous opportunity for testing because of the leadership position that we're in. And then how do we get our message out there? Working with the Ministry of Economic Development and Innovation, working with MaRS, trying to bridge the innovation gap, allow for more innovation in the electricity sector. And I think you're going to continue hearing more and more out of this, even through things that are, kind of have their own train going down, like the feed-in tariff review. You'll hear more about the feed-in tariff review next month. But part of the feed-in tariff review is emerging technologies. What are we doing with that? How are we going to continue to encourage those things? This is a discussion we need to keep having.
If I could just add a point. I think, John, you've made a very valid point about these development and pilot projects. It's extremely important that like the government setting policy can also put great incentives in place, and things like the Opportunities Fund, the Smart Grid Opportunities Fund, give utilities an opportunity to, and third parties, other stakeholders, an opportunity to develop in areas that wouldn't normally be in their traditional scope of work, simply because of regulator approval concerns. So there are a number of incentives that can move these pilot and demonstration projects along.
If you have any questions at all, just head up to a mic and. Go ahead.
Yes, hi, Arthur Privo. Thanks a lot for everything. I just wanted to note several of you were referring to data management and the fact that there is more and more data and people have to use it in a smart way. And for small companies that don't have like big capital, that's where an area where a small team, I guess, can maybe make a difference. And I was wondering if in what you see from the industry, that's already one area where the big groups, those 6 big companies that you were speaking about, if they are already all over it, or if it's still one area where there is a lot of room for small companies to try and do things. Thanks.
Sure. Sorry. Yeah. I don't see those 6 companies. Those companies are largely in the business of making switchgear and transformers, right? The data piece of it is a new area that they're breaking into. I do see that there's opportunities for the startup companies that, this doesn't require to build a factory. It really just requires some smart people together making some software. What I've seen from all this data, we talk about this data tsunami. It's largely data that we've had on the transmission system, and we're now going to get it on the distribution system. And so it's a lot more of it because the distribution system is 10 times more wire than the transmission system. But these are, my personal belief is that these are problems that have been solved in other industries, right? The banking industry has high volumes of data that needs to be done. Every single time you run a credit card transaction, that credit card transaction is checked against a bunch of fraud measures in a very quick way, and an answer comes back to say, yes, allow this to go, or no, deny the credit card. These are issues that have been solved in other industries, and I think if we took those lessons from those other industries and the ideas from those other industries, I think there'd be a lot of value for the utilities. But no, I don't see they're getting into that space, but it's not, it's more the IBMs of the world that are trying to get that business.
If I could add to what Alex has said, operational data information. Data is worthless. It's taking that data and producing useful information, bringing that data from where it's stored, manipulating it, developing those algorithms that puts this data in front of an operator or planner or designer in such a way that they can access it easily and use it and make it a part of their daily routine. This, from a utility, I'm speaking from our point of view, this is the greatest opportunity that we see. It's the lowest lying fruit that we have to avail of. We've talked about, the industry has talked about interoperability, a big word that really just looks at the ability to share data amongst many of the platforms. For the most part, that issue is not as big today as it was a few years ago. Everything seems to be talking to each other. There's a great sharing of data. There's very little proprietary protocol information. But our challenge, and why we can work with smaller companies, is to develop useful ways of mining that data.
If I could add quickly, two recent acquisitions that have occurred in the past 3 or 4 months within that field is, I think in December or November, eMeter was acquired, meter data management company was acquired by Siemens, and recently, or maybe vice versa on the timing, Ecologic Analytics was acquired by Landis & Gyr, which is owned by Toshiba. So some of these companies are certainly taking a very active interest in smaller companies within this data management space, so it's something that if you're interested in it, now's the time to kind of jump on the bandwagon.
Go ahead.
Morning. Perhaps something for the Johns. We've got the utilities trying to work to implement smart grid. We've got the government embracing that. And John, you alluded to it, and Mel Rooney, you alluded to it in your conversation. The OEB is in the middle, and the OEB really is doing a prudence test in a traditional regulatory manner. I wonder what's happening with the OEB to be that facilitator moving smart grid forward rather than a prudence that it's been in the past.
Good question. Maybe I could start, and sure. I think this. The OEB, of course, comes under Ministry of Energy, but from the utilities point of view, we're finding that there has been a directive from the Minister of Energy to the OEB to review how it handles and evaluates smart grid. We went through that initial period after, I guess, early 2009, when the IESO released its smart grid. The IESO Smart Grid Forum released its first report. We've been in a holding pattern, but the regulators allowed us to use deferral accounts to be able to manage some of these borderline prudence projects, pilots and demonstrations being a great example of that. But I find that from the utility point of view, the regulator is changing, and they're adapting to this new requirement, probably faster than most utilities.
Yeah, I agree. One of the reasons we put in place a whole legislative framework around smart grid was specifically to help create that environment where the regulator actually can do these sorts of things, can go out and is in fact forced to go out and think about asset management for utilities differently. The OEB has sent signs that they are reforming the way that they're looking at regulation. It doesn't take us away from a fundamental fact, which are that distributors remain natural monopolies and will for the foreseeable future. So they require some form of regulation. I think this is something that's not a struggle unique to Ontario. I think anywhere where you're having smart grid technologies being employed in the distribution system have similar issues. One thing I would point to, though, Alex mentioned the transmission system. Instead of looking to other industries, look to the transmission system as a model for this. The drivers on the distribution system now are really the distributed generation, the need for more visibility on the loads, the need for more visibility on the system, are really similar to the drivers on the transmission system and why they have that level of control. In fact, you could argue that distribution of the future is really moving towards low voltage transmission systems. And again, both are very regulated environments. So it's certainly not, it's not an impossible curve to try and go down. The time frame for that kind of proof of concept is part of the reason that we're trying to do these demonstration level projects now.
Morning, John. How are you today? My name is Gustavo Brunello. I work for General Electric. So I have some, first of all, clarification, then 2 comments. We are not the big brother of anybody, and we have no sisters. By the way, this year, as some of you may know, we are opening our new plant in 404 and Major Mackenzie. We are building a 400,000 square footage, and we are having a world headquarters for some of our smart grid solution right here in Toronto, Markham. So we are investing heavily in this here in Ontario too. Now, I have two questions. The question does not reflect the policy or the position of my company, rather my personal position. So yesterday I was talking with some consultants here in Ontario. They are very involved in the interconnection of renewables to the grid. And this consultant mentioned to me that the renewable will never take off really until the government of Ontario doesn't have a policy for energy storage. So something similar like the feed-in tariff that we are having for renewables. That's one question. The other question regarding the data, the information, as John rightly said, we are having this smart grid vision will have an explosion of data that then smart people will translate into information. I was also shocked to see these Berkeley people complaining about the smart meters, so I started to read why is that. And certainly these people are concerned about the information, the provider of energy, that they are getting from the individuals. And some of your panelists said these companies are private companies which are very, very eager to maximize the profits. So this smart grid we have to face will provide a huge personal information to people. So how are we protected? What is the benefit that the individual, the user, the residential customer gets from that in exchange? So people will pay higher price with this time of user meters and are having no benefit because they are basically given for free their way of life, when I do turn on my TV, when I do my washing, when I cook, and so on. Thank you.
Two great questions here. One on energy storage and feed-in tariff equivalent and policies around energy storage. Are we seeing anything? And then the second part was on information from smart meters. How is it shared and how is personal information protected?
I could touch on the first one, on the energy storage, which is something that is kind of near and dear to my heart, something I've been focusing on the past 6 months or so. Certainly, energy storage is a major issue. One of the big things I can focus on from an American perspective, from policy-wise, because that's my main coverage area, is defining, in most utilities, there's generation, transmission, distribution. But storage falls on, kind of sprinkles in different components of it depending on how you configure it and where you physically locate it. So one of the things that California is looking at is defining a new asset class for energy storage. And this would have a tremendous implication on that industry as a whole if they could redefine and revalue and properly compensate energy storage for the multiple values that it has. One of the biggest issues with most smart grid technologies is that in a deregulated market specifically, one entity may put some technology in their network, but it benefits all the way downstream to other networks. So how do you properly recapture that value from a cost-benefit perspective when there's multiple entities that benefit from a single investment? So this is a major policy issue, and I agree that energy storage technologies right now on their own, based on the way we define generation, transmission, and distribution, are not, in the most case, cost-effective, except for something maybe like pumped hydro. I'm talking about emerging energy storage technologies. So we don't expect to see the costs of most emerging energy storage technologies to drop low enough without a bringing up of the bar of policies to make them more valuable. And a good example of that in the US recently was the pay-for-performance ruling that more appropriately values frequency regulation in certain US markets. So that's a good example of these type of changes that hopefully will be the model for the rest of the world within that market.
Okay.
Yeah,
do you want to take the open data and protecting personal information question?
Sure, yeah. And I was just going to say on the storage piece, I certainly agree with Brian that it's something where the value of the storage is actually very important to determine. A lot of jurisdictions are grappling with this. You know, to simply have storage in a feed-in tariff type construct would probably be an inappropriate mechanism for storage, because that's a construct where you're looking at the cost of the technology and providing a return on top of that because the technology is good. But the real question is, what's the value of this battery system? What's the value of this compressed air system? And utilities and electricity sectors all over the place have to do a better job, including us, of recognizing that. On the privacy piece, there were a few different questions actually nested in that privacy piece. I mean, I would respectfully disagree that that time of use pricing in place now in smart meters really just have increased costs and not provided any benefits. I think they have very tangible benefits actually, and the proof is in the pudding as the data is going to be coming out over the next year or so as to the extent of load shifting that we've seen and the value of that load shifting to the system. Beyond that, it has outage management benefits, and of course there's a value to the data itself that can be taken advantage of in the future. Now, how that data gets taken advantage of, if it's customers using it in home energy management systems and so on, which really does go down to the level, okay, what appliance is doing X, what other appliance is doing Y, then absolutely we need to consider the privacy implications of that incremental change. What's been done to date is actually very privacy neutral. Any data that's going to a central data repository is completely anonymized, can't actually be traced back to the customer data. So it's in some ways inherently safe. There's also security features on the smart meters themselves. But as we progress that, if we do nothing, I mean, the best thing for privacy is to do nothing. Don't collect information. That's the safest thing you can do for privacy. We have, in the legislative framework we put in place, to make sure that the smart people are going to be looking at this stuff, what are the privacy systems we can use, nested a principle of the Privacy Commissioner of Ontario called privacy by design in law, so that privacy assessments will have to be an ongoing part of smart grid planning. And in fact, if any incremental change is happening, the privacy piece is up front to be able to explain that, yes, there's risk X, risk Y, risk Z, here's how they're being mitigated.
Thanks, John. So we're actually at our time mark, but we can take one last really quick question.
My name is Peter Dower, and I used to be at Hydro, although not in operations, the old Hydro. This is a question about where you see the utilities themselves at the spectrum of innovation. In my days, we used to have a department that specialized in nothing else. Not always successful, but they generated an awful lot of ideas which were not really part of the central role of the utility itself, but had all these ancillary benefits, and the smart grid would, in those days didn't exist, but it would fit into that pattern. Where do you see the utilities doing that kind of work? And some of this may be available to outside companies in terms of purchasing patents and that kind of thing, as universities and hospitals do.
If I may, that's a great question. What we as utilities don't do is research and development. That's left to industry. You have to go back to the corporate vision and your corporate objectives. And with PowerStream, one of our corporate objectives is to be an industry leader. So it means that we're going to be looking at technologies, and we have a specific way of doing that through our smart grid task force, comprising 10 of the most senior people in the company, and through departments like mine to look specifically at new technology. And any new technology that comes into the company comes in through the smart grid department. And we look to try and take advantage of that. But I do stress that, and particularly in the context of pilots and demonstrations, that we are not an R&D company. We don't have those resources. We don't want them. But we do have strong formal associations with Queen's University and Georgian College, and we've had work done with the University of Waterloo. These are the institutions and companies like that are represented here today. These are the ones that we want to partner with, as long as we can be convinced that at the end of the day, that direction could lead to a benefit to the customer.
In other jurisdictions, like so you worked for Ontario Hydro, and Ontario Hydro had an R&D arm, and that got spun off into Kinetrix. Now Kinetrix is a private company. Quebec still has their IRAC. I think IRAC is mostly owned, if not wholly owned, by Hydro-Quebec. BC Hydro had PowerTech. They spun their off, now it's a private company. I think there's just been a real shift in the industry from taking that internal R&D and moving it out to, EPRI, PowerStream. IREC, the Hydro-Quebec owned, is one of the world leaders in transmission R&D. Like, their transmission R&D facility is second to none on Earth. Getting this R&D down into the distribution system and along smart grid applications is something that they're getting into. I think but the general industry trend is to outsource it to EPRI and Kinetrix and companies like that.
Thanks. So with that, I want to thank our panelists for a lot of great insight today into the industry. There's a few other people I want to thank also. Jessica Briones, who runs our Clean Tech Market Intelligence, worked hard on pulling together the white paper and the infographic, so I want to thank her for that. Also, some of our other partners that help with this morning, so Ontario Centre of Excellence, the Canadian Solar Industry Association, IEEE, the Ontario Sustainable Energy Association. Thanks to all of you for your help. So we heard a lot today, and I'm really glad that we had this. It helps get people onto the same page and gets all of us thinking about things together. I encourage all of our panelists and our entrepreneurs to stick around. If there are more questions, please to try to grab them and use this as a good networking opportunity. Because we have a lot that we have to do. You heard the figures earlier on how much other countries are spending on smart grid infrastructure. So we're going to have to be really coordinated in our effort. We have our utilities, as mentioned, they don't do the R&D. Our Ministry of Energy, they're focused on Ontario here. They don't really have the economic mandate. We've got our entrepreneurs that are probably wondering where that leaves them. So we have a lot of work to do together to try to coordinate things, get some pilots done and demonstrated here, and figure out what we can supply to the rest of the world so that we can generate some strong manufacturing jobs in this industry. So I want to thank all of you for attending and encourage you to stick around. Thanks.